Hi class. What I want to do in this video is I want to walk you through an application problem of the sampling distribution of the sample mean. And as I go through this application problem, what I'm going to do is I'm going to show you how to use your calculator to answer this. So what you should have handy is you should have your TI-84 or your TI-83 calculator ready to answer these problems. Okay? All right, so the problem goes like this. According to Apple Incorporated, the charge life, what a charge life is just like if you charge your phone fully, how long it takes till it dies. Okay. On the iPhone 8, well, that charge life is normally distributed, so it follows the bell curve with a mean of 29 hours and a standard deviation of 8 hours. Okay, so on average, these iPhone 8s last 29 hours. Mine definitely doesn't. And they have a standard deviation of 8 hours. So suppose a random sample, so we're going to take 30 iPhones. Okay, 30 iPhone 8s is taken, and the mean charge life of those 30 iPhones is calculated. Okay, so the first phone's going to have a charge life of whatever, second phone's going to have a charge life of whatever, and we're going to define this variable. We're going to let x bar be the mean charge life of the 30 randomly selected iPhone 8s. So the first question here says describe the sampling distribution of x bar. Well, what the sampling distribution of x bar is here, if we look back at the central limit theorem that we talked about this week, central limit theorem says as long as the sample size, and this right here is the sample size, okay, this is my n is equal to 30, sample size here, as long as the sample size is greater than or equal to 30, which it is, the sampling distribution of x bar will be normally distributed with, so the average of the averages, well, it turns out that that's going to be equal to whatever the population mean is. Well, I'm telling you that the population mean is 29 hours. And the standard error, okay, or the standard deviation of the sampling distribution is equal to, you're going to take the standard population standard deviation, which I told you was 8 hours, and you're going to divide that by the square root of the sample size, the 30 hours, okay? Or the 30 iPhones, excuse me. And if you grab your trusty calculator, I'll do it on this calculator here. I'm going to take 8 divided by the square root of 30. You're going to get 1.46, right? So I'm going to round that to 2 decimal places. Okay, so the sampling distribution of x bar is going to be normally distributed with the average of the averages is equal to the average, which was 29 hours. And the standard error here, you take the population standard deviation, which was 8 hours here, and you divide it by the square root of the sample size, which is 30, and you get 1.46. Okay. So now we're just going to do some probability questions here, all right? And I'm going to show you how to use your graphing calculator for this. So what is the probability that the mean charge life is less than 28 hours? Okay. So you're just going to go back to using that second function distribution, and you're going to want normal CDF. So normal CDF. So the lower bound here, okay, I want to be less than 28 hours. So I'm going to put negative 99999 for that. And then I want it to go up to 28 hours. So leave 28 there, if you had that from a previous example. The mean was 29 hours, but now the standard deviation was 1.46. Okay, it's no longer that 8, it's that standard deviation divided by the square root of the sample size. So over here on the TI-83, you're going to hit second function distribution, normal CDF, lower negative 9999, comma 28, comma on average it was 29, comma the standard error was 1.46. You're going to hit enter, and you should see you get the same thing. So I'm just going to round this to 0.2467. So the probability that x bar is less than 28 is equal to 0.2467. Just like that. Okay, let's do the next one. What is the probability it's more than 32 hours? Okay, so that's what I want to find here. The probability that x bar, let me flip that, is greater than 32 hours. So we're going to go back, second function distribution, normal CDF. So now the lower, you want it to start at 32 hours, and you're going to go up to 9999 like that. The mean and standard error doesn't change. So over on the TI-83, you're going to hit second function, distribution, normal CDF. The lower is going to be 32, comma, all the way to 9999, comma, 29, comma, 1.46. Close the parentheses, and you're going to get a small number here, 0.0199, when I leave it like that. All right. So finally, what is the probability that when I do this, my x bar is going to be between 28 and 32 hours? So the x bar is like that. Well, actually, what you could do is you solve this by figuring out actually it's not this minus this. You have to be careful with that. But the easiest way again is to just use your calculator. So you're going to go second function distribution, normal CDF. Well, now here I want to be between 28 and 32. So my lower is 28, my upper is 32. I'm going to go down to paste. Over here, you actually have to type it all in again. So I want to be between 28 and 32, and the average is 29, and the standard error is 1.46. And look, you get the same thing, 0.7333. All right, class, I hope this helps. I'm going to save this file, and I'm going to post it for you to the classroom. Thanks.